warahmatullahi wabarakatuh and salam sejahtera. So this video we discuss talk on a call as well as some of the application for this chapter. Okay, for talk on a call, if you have a magnetic field and then you have current carrying conductor, so if the current carrying conductor sits in between magnetic field, you will expect to have a force. So the force that actually helps the object to turn, that one is what we call a torque. So in this subtopic, basically we just want to apply force on current carrying conductor, but now the object returns into circular motion. Sorry, not circular motion, it will turns lah, it will rotate. So we have one particular formula here where torque is equals to NBIA sine theta. Okay, where N is numbers of turn, B is the magnetic field, I is the current that flows inside the current carrying conductor, A is the area, and sine is the theta. Theta here is actually the angle between magnetic field and vector A, area. Okay, area vector is actually 90 degrees to the surface. Okay, it really looks like a normal force tu kan, ingat tak, normal force is actually perpendicular to the surface. So similarly for this one, so your A is actually, in this case, A is pointing upwards. Okay, now let's look at the direction of turn. So you expect this one has a torque. You have a force that produces a torque, and this object will rotate. Okay, that's the idea. Now, if you're only looking at one compartment here, one parts here, and this one's another part, this one another part, and this side will be another part. Okay, if you are focusing on this part first, okay, so the current is actually moving in this direction. Okay, so magnetic field move in that direction. So if you want to try, you can use your thumb over here. Okay, because this drawing is actually 3D, so susah sikit saya nak ni. So they actually kamu akan slap to the front, and then they akan, sorry, not front, strap it downwards. Okay, like I told you, if 3D is really hard to explain, you guys might have a different view, but now I want to show you this one. Okay, this one is basically the same thing. This one, except basically I just put like a paper over there. Okay, so this one is going into the page, this one is going out from the page, so you have this kind of symbol. Direction of B is still the same, which is to the right. Okay, and then you have to determine the direction of force first. Force dia ke mana? So nak tentukan, you can use step rule. This is your B ke kanan. Your current is into the page, masuk dalam. And then if you want to determine direction of F, it will be slap ke depan. So it will be downwards. Okay, if you try this one, you will get upwards. So you have two force acting on this coil. Okay, so one is going up, another one is going down. So you expect that you will have a rotation in that direction. Okay. Okay, so this is one of the example on how to determine the direction of A tu. Some students, they got confused about it. So if A and B in the same direction ataupun same direction lah, theta is equals to 0 degree. Okay, if it is perpendicular, then it will be theta equals to 90 degrees. Okay, the angle between plane and magnetic field is actually this one. So this one is a bit tricky. If they give you this kind of question, biasanya dia akan kasih nilai alpha ni. Dia jarang kasih nilai theta. So you have to calculate theta by 90 minus theta. Okay, please be careful with this one, especially A punya vector tu. Okay, So one of the application for this subtopic, torque on coil, is actually galvanometer. Okay, moving on to the last subtopic, which is about applications. Okay, so some of the application is velocity selector and mass spectrometer. So normally these two exist together lah, dia datang sekali. So biasanya dia go through this one first and then they go through this one. Roughly it looks something like this. Okay, tapi saya rasa saya akan kasih a video kot on YouTube yang ada. Hopefully I can find one that with a simulation ataupun animation so that you can understand it better. So normally this one consists of two part. One is velocity selector, this part. Another one is mass spectrometer. So I just label vel and mass. Okay, so inside the velocity selector actually consists of like a small slit. Okay, and obviously you have magnetic field that we try to deflect the charge, but the charge only at specific velocity will pass through the slit too. If charged to more than how it should be, the velocity is a little bit higher or a little bit lower, it will end up over here. Okay, at the surface wall too. So the only particles that passing through this one is at a certain velocity. That's why we call this one as velocity selector. So immediately you know the velocity of the particle as it goes through here. Okay, that's the concept. Okay, for mass spectrometer they use a very similar concept. So you know that if you have a particle, they will try to move in circular motion. Okay, under magnetic field lah, constant uniform magnetic field. But if you have slightly higher mass or lower mass, then you have bigger deflection or lower deflection. So based on that, you can determine the mass of the particle. Okay, so this is one of the application. Okay, I think I give you video later on, this one with the galvanometer as well. Okay, the formula for this one ada few. One is V equals to E over B. Okay, yang lagi satu tu I think you can found in your lecture notes. Like this one, Q over M is equals to E over B R. Okay, so this one is actually for mass spectrometer tu dekat sini. Okay, I think you can try to read again your lecture notes by yourself. Sepatutnya tak ada masalah for you guys to understand it and to apply it. Maybe I think maybe we might have to do some of the tutorial question as well. So I will pick few questions and I will try to finish up for you. Okay.